Okay, let's talk through the answers for number 3 on this worksheet. In the space to the right, it says to draw a diagram of the initial conditions of this problem. So, effectively, what I wanted you to do is I want you to look at the horizontal and the vertical velocities. 25 meters per second for the horizontal direction, and then 45 meters per second for the vertical. Now you can skip B and C. B and C effectively is just talking about, well, if I were to connect these, what would be that total velocity? And you can see it's basically going to be a hypotenuse of that right triangle, and then you got an angle here that requires some trigonometry. All right, so moving on from there, let's go to part D. How long will it take for the ball to go up and come back to the ground? All right, so on part D, we're going to look for the what looks like the hang time. So first of all, we know that the acceleration is going to be equal to negative 9.8 meters per second squared. All right. So when we're talking about hang time, we're talking about the amount of time it takes to go up and come back down. The only thing that's going to affect that is going to be the vertical direction. If you remember us talking in class in the videos that we've shown, that the horizontal direction has no bearing on how much time it takes for the object to fall. An object that is moving horizontally and an object that is dropped will both fall at the same rate and hit the ground at the same time. So when I'm looking at how long it's going to take to fall, I'm going to look at just the vertical direction. So the acceleration in the vertical direction, which is the y direction, is going to be equal to negative 9.8 meters per second squared. The initial velocity, also in the vertical direction, is going to be this 45 meters per second. All right. The 25 meters per second, again, is a horizontal velocity, and that has no bearing on how long it's going to be in the air. Only the 45 meters per second is going to affect how long it's in the air. And then we have a displacement of 0. So I actually call that displacement in the y direction of 0 meters, because as it goes up, comes back down, it starts and ends at the same height, which means the total vertical displacement is 0. Now it's going to go horizontally. There's going to be some horizontal displacement. But as far as the vertical direction, there is no displacement from the beginning to the end. No vertical displacement. All right, so looking for time, that's going to be our question mark. So then we have the acceleration, initial velocity, displacement, time. So displacement in the y direction is going to be equal to 1/2 times acceleration in the y direction times time squared plus the initial velocity in the y direction times time. And I'm just saying the y direction just to make sure that we're talking about just the vertical direction, not including the horizontal direction at all. So displacement is 0. That equals 1/2 times negative 9.8 times time squared plus the initial velocity, which is 45 times time. All right, so 0 is going to be equal to half of negative 9.8, which is negative 4.9, t squared, plus 45t. Now, how you solve it from here is totally up to you. I'll go ahead and see that there's a common factor of t in both of these. So let's factor out that t and then divide both sides by t. So you can see that t is going to cancel from this term and from this term. Only one of the t's cancel here. So then that leaves us with 0 is going to be equal to negative 4.9 t plus 45. Take that negative to the other side. 4.9 t equals 45. And then divide both sides by 4.9. And that gives us that the time (45 divided by 4.9), 9.18 seconds. All right. So part E, how high does it go? What's the highest that it goes? All right. So first off, part D, that's referred to as hang time. Hang time. All right. E refers to max height. The highest it's going to go. The highest it's going to go. All right. So for the max height, part E, again, we're looking in the y direction. We're looking in the vertical direction. So that means the acceleration is negative 9.8 meters per second squared. The initial velocity, 45 meters per second. All right. Now, what do we know? We're looking for the max height. So we're looking for the displacement in the y direction. All right. Now, at the top, the final velocity is going to be equal to 0. All right. If you remember before, when an object goes up and when it gets to the very top of its path, that velocity is going to be 0. All right. So knowing all this, we got final velocity in the y direction squared is going to be equal to the initial velocity in the y direction squared plus 2 times acceleration in the y direction times displacement in the y direction. Plug in our numbers. The final velocity is 0 squared. That's going to be equal to 45 squared plus 2 times negative 9.8 times delta y. All right, so 0 equals 45 squared. That's 2025 plus a negative 19.6 delta y. All right. Please do not subtract these two numbers because this is a term that's being multiplied by a displacement. All right, so we bring this this 2025 to the other side, get negative 2025. That's going to be equal to negative 19.6 delta y. Then we divide by negative 19.6. So that means our displacement in the y direction, maximum displacement is going to be 2025 divided by 19.6. And we get that's going to be 103.3 meters. So 103.3 meters. Okay. Part F talks about how far it will travel. So it's talking about the horizontal direction. Okay. This also has a special term. We call that range. What's the range of the object? Okay. Now, since we're talking about horizontal, that's where we start talking about this horizontal velocity of 25 meters per second. But we also know that the time is going to be 9.18 seconds that it's in the air. So that's two things that we know about the horizontal direction. We know that, so for part F, the horizontal direction has an initial velocity. Initial velocity in the x direction is 25 meters per second. The displacement is what we're looking for. So that's our question mark. The time is 9.18 seconds. So the interesting thing about this is we also know that there's no acceleration in the x direction. So 0 meters per second squared, which means we can use constant motion, the constant motion equation. Constant motion. All right, constant motion is velocity equals displacement over time. Now, what if you use the accelerated motion equation? Well, what you're going to find is actually you'll get the same equation. All right, so if we multiply the other side by time, we get displacement is going to be equal to the velocity, and that's the velocity in the x direction. The velocity in the x direction times time. Well, let's say you use this equation. Displacement is going to be equal to 1/2 times acceleration times time squared plus the initial velocity times time. So keep in mind, with 0 acceleration, this term actually is going to go away. And what you're left with is you're left with displacement equals velocity times time. So you actually get the same equation either way, whether you use the constant motion equation or the accelerated motion with 0. All right, so we plug in our numbers. Displacement is going to be equal to that velocity, which is 25. Now, recognize we're dealing with just the horizontal velocity, times 9.18. All right, punch that in, 25 times 9.18, and you get 229.5 meters. So our range is going to be 229.5 meters.